Hello, everybody. This is Jeffrey Hensler from Eastern Applied Research. I'm going to start up the webinar right now on increasing quality control efficiencies through X-ray fluorescence analyzers. This is sponsored by Hitachi High Technologies and presented to you today by Eastern Applied Research, and that includes me, Jeffrey Hensler. Just so you know, I have about 10 years of consultative sales in X-ray fluorescence. And then I also have on the line with me Bob Mull. Bob, you can say hello.
Hello.
There he is. Bob has over 30 years of experience in applications, service, standards, and sales across a wide range of brands of X-ray fluorescence. So at the end of this, if there are any questions or points to clarify, Bob's going to be the go-to guy for applications and use of the equipment. So first, just want to say before we really get into it, 2 points. This is our first webinar, so hopefully it's information that you find helpful in your use of X-ray fluorescence. And any feedback on topics that you'd like for future webinars would certainly be appreciated. We're going to take it all into account and hopefully have a few more of these down the line. Second, the videos that you see, it's going to be a mix today of slides or PowerPoint presentation and videos. The videos are the actual software of the Hitachi system, and that is pre-recorded. So if at the end of this you have any questions relating to the software flow, things you'd like to see, let us know. We won't be able to show you immediately, but we can take videos or do webcam demonstrations and get you exact answers to the questions you might have relating to software. So with that, 2 other points on your screen. Looking at it to the right, you're going to see a Q&A box. You can add any questions you have about anything we're talking about software-related wise, specific applications that you might have and you're trying to tackle, or throughput reporting functions, anything we might talk about, throw in the Q&A and we will get to those at the end or follow up with you later with some answers and information. Also on the right-hand side, you should see resource buttons. That's links to the Eastern Applied website, easternapplied.com, where you can get information on the system. And there's also, I think, a LinkedIn where we do updates relating to X-ray fluorescence above and beyond just what we do. So the topics we're going to tackle today, it's going to be about probably in the 20 to 30 minute range. Again, a mix of PowerPoints and videos demonstrations. We're going to introduce the Hitachi FT110A XRF analyzer. That is one of the newest XRFs to market and what we're featuring in this webinar when we're talking about functions and features that can help throughput. Then we're getting into adding calibrations, standard lists versus empirical methods, best practices on getting through, throughput features for sample alignment. A couple features that the Hitachi system includes is autofocus and wide view observation. That has very nice benefits when applicable. And then we'll talk quickly about the reporting functions. So getting into the guts of this, the evolution of Hitachi, just want to point this out. Many of you may be familiar with the Seiko line of X-ray fluorescence equipment from the 80s and 90s and early 2000s. They had some very popular systems, and that has evolved into the Hitachi line of X-ray fluorescence equipment. So there you can see the Seiko models that you may or may not be familiar with, the current Hitachi models, and what their uses are. Top 2 there are for hazardous substance and elemental analysis. I do want to point out the 6000VX. That is uses a vortex detector silicone drift pin. It does ROHS, material identification, and also applications like phosphorus and electroless nickel. We're getting a lot of questions about that. That's a very nice system for that. The FT150 is also a silicone drift system with polycapillary optics for thin film and microspot analysis. But today we will be focusing on proportional counter systems for coating thickness applications. Anybody that knows Seiko knows the Seiko SFT3200 and SFT9200. That has evolved into the FT110A that you see there. And that is the software that we'll be reviewing today. And just aside, the software across the board for Hitachi is very similar, very streamlined. So anything you see today, it's going to be pretty much the same on any of the new Hitachi analyzers. Here are specs on the FT110A. This is available at our website again, and we can certainly send it off to you if you want to. The proportional counter detection system, most popular for coating thickness applications because it's a lower cost detection system that meets the testing requirements that most people have in coating thickness. And this system, I would also point out, does have a very deep chamber of 7.5 inches high, which is useful for flexibility, and it has an optional XY stage. When you get into the XY stage, again, just want to give you the overview of the FT110A. The XY stage has the optional slotted chamber design, which is useful for circuit boards, any long items that you might have, and that's a nice diagram of the depth there. So with that overview of the Hitachi FT110A out of the way, we're going to get into some aspects critical to quality control efficiency. And Bob, if you want to jump in at any time with any thoughts on specific applications, thoughts that might be useful from your experience, please do. Otherwise, again, questions and answers at the end, and we'll look forward to tackling those. The topics we're going to cover, we're going to basically just go through how you would set up a system, take measurements, and get into reporting in that order. So calibrations, depending on your experience with X-ray fluorescence, you may or may not know the different options for calibrations. Historically, empirical calibrations was the way to go, and empirical is simply using known reference standards to add calibrations to your XRF analyzer. And the positive side of empirical is that you can, at times, in certain applications, see higher precisions. The cons, as you see listed there, is that the cost of reference standards could add up if you do a wide variety of applications, and there's a setup time that you have to get through. So because of that, organizations started looking to standardless calibration capabilities, also known as fundamental parameters, or FP. And this removes the need for so many reference standards, simplifies the calibration process. And a note here is that the Hitachi system does come loaded with a range of elements in the library so that the operator doesn't have to add the ability to do certain applications, the operator can add the ability to do certain applications without calling in Eastern Applied Research or Hitachi. Some of the other systems on the market do require that, and that would be a cost to the operator. But Hitachi has it all in one. A little bit more about the FP. Hitachi in the Seiko days did have an FP program. It was a good program, but it got better because they realized that the need for streamlined addition of calibrations with accuracy was critical. Proportional counters do a nice job, again, on coating thickness measurements, but the issue comes in with the large spectrum overlap where you could lose some accuracy on certain applications using fundamental parameters. As a result, sensitivity coefficient needs to be obtained when you're creating these conditions, and in the empirical method, you'd use reference materials to get that tight. But now, with the Hitachi FT110A, they worked on developing a new process that combines the characteristics of the proportional counter and also enables measuring through a sensitivity coefficient that's registered beforehand. That results in improved performance across the board by omitting prior operations, and by omitting operations, you streamline the process involved. So it's all about just higher efficiency in the lab. Right now we're going to look at a quick video that Bob Mull put together on adding calibrations. So you can believe it, it's demo time.
I'm going to show you FP method today. We go to File, Film Analysis FP. The one below it would be for empirical if we were going to do it that way. Select Film Analysis FP. I'm going to hit the eraser for clear, and we're going to start with a fresh palette. Analysis conditions is here. Best condition is what we're going to use. Next, input layer. I'm going to do a zinc over steel calibration, so it's 2 layers. We're going to drag the zinc up to that component for layer number 1 and iron up for component number 2 in the base. Over here, these are just text boxes. We can type in zinc or anything you want, and I'll put in steel here. Hit next. On this screen, we can select the units of measurement from microns, angstroms, microinches, mils, and so on. I'm going to use microinches. The concentration would be used if this was a zinc nickel application, for example, or possibly a solder. You would hit your weight percent or the units of the concentration. Down here is how many decimal points. I'm going to use 2 decimal points for the output format for the thickness and for the concentration if I was doing concentration in this example. In this screen, we select the density of each material. I'm going to use the default density. However, if you had some special alloys or something that you were working with, or some special method that may plate at a different density, we could edit it here. In this screen, you put in your initial values. My target value is usually what I put in here. So if I want to plate, let's say 400 microinches of zinc, I might put in 400 here. Down below, you can select your collimator. This machine has 2 collimators. There are options where you can have 4 collimators, including slotted collimators. But I'm going to select the 8mm collimator here. Focus. This is one of the nice features of this machine. You can have several different focus layers, up to 3 inches or 80 millimeters. For those odd-shaped parts or deep recesses, we can pick different focus lengths. I'm going to pick 30 millimeter. I like working with that one. It's more comfortable for me. Then I'm going to hit OK. In the next icon, as you'll see, we scroll right across the icons. This is where you would enter a standard value. Let's say you had a standard value for zinc you wanted to put in. You could enter it here, type in the value of it, and we could calibrate it in later. I'm not going to use any standards in this method. It's just not needed. In the next icon, we're going to do our measurement mode, or measurement times. The unknown mode is for your samples. I'm just going to select 10 seconds for that nice quick measurement time. But if I was going to calibrate in standards, I would use a 100-second measurement time in this example. They default to this, but they're editable and you can change it to what you like. I'm going to hit OK here. And our next icon over, this is where our calibration standards would show up in the upper right hand corner if we had entered standards, and we would click on one, place it on the stage, and measure it, and that's how you enter it into the calibration. It's very easy. Down below you'll see the list of pure elements that are already in this system. We have a pure element library stored into this, so once you put in an element, FP uses that for your calibration. You can see I do have a zinc and an iron already stored in here. That was done once, and it could be used for years after that. Now to measure, we're going to go to the unknown mode, zinc over steel, open up the camera image here, and I already have a zinc piece in place. You can simply move the stage by moving your mouse and clicking, as you can see. I have autofocus on, so it automatically focuses this system. I'm going to use my auto approach feature here to get the head height right to the 30 millimeters that I selected. Auto focus is on, and I'm going to hit start. We'll wait to 10 seconds. Down here in the lower left is your status bar. Shows you the measurement time and the dead time. We can move the camera image over here and increase the spectrum so you can see the different elements and position it even further for your zinc and your iron. If your camera window is too big for you, you can make it 25% and put it over here, for example. And you'll see down in the lower right hand corner is our thickness at 389.1 microinches. Let me show you what standard that is. I'll go back up to 100%. and it is a 386 microinch standard, 386. You can see how quickly FP can be calibrated, how accurate it is. Standards aren't necessary, but you may want to put it in for traceability.
Okay, so it looks like that first video is done with the process of adding calibrations. We have a couple more videos coming up showing the software, and I just want to reiterate that if you have any questions about the operation, the software specific, please send them to us in the Q&A upper right of your screen, or contact us after the fact. We can get you copies and make sure that the screen is clear enough so you can see it, because I'm not sure how it's coming through. You can also expand that screen on your computer, so hopefully you can see everything that you need to. But we're here to help if it's not coming through right after this is done. So then after you have the calibration added and you're getting into taking measurements on a day-to-day basis, one of the greatest methods in streamlining the process is fast sample alignment. And Hitachi, the FT110A, has a couple features that really helps get through that process. It streamlines it, and it also removes the variable of operator so that you don't have to rely on them. It's more cut and dry, and you can get consistency across the board. One of those features is the wide view observation system, and I believe this is unique to the Hitachi line. It is essentially using two camera systems, one to take a wide view screen of the system. You can see there it's about 9.8 inches by 7.8, and it can fill that entire area or a portion of that area. The second camera system is considered the narrow view, and that is where an operator can pinpoint an exact spot on the larger sample to make sure they're getting a very exact measurement and getting the right spot that they need to. Certainly common in circuit boards, as our example there shows, and it can also have application when you're working with jigs of multiple little pieces. Anything where you've got small areas to measure within a larger sample. And that benefit is efficiency. Again, it saves operator time and the potential mistakes of alignment, and it just streamlines the process as a whole. And just so you know, the wide view, in the video that you're about to see, the wide view isn't shown the process of getting that wide view, but it takes as little as, or as long as 20 seconds, but typically it's 10 seconds. It depends on what's going on in the sample area, but pretty fast to bring that up, and then high resolution so you can pick exactly where you need to. So with that quick overview of wide view observation, we're going to get into a video that can show you what it can do.
I'll now show you the wide view feature. You will see an entire printed circuit board in the right-hand window. If any of you have ever done this, it can be difficult to find the certain pads that you want on a large circuit board. Many of them are duplicated. But in this one, it'll be easy. I want to measure on the lower left-hand board, the lower left-hand pads. I will simply click in the lower left-hand corner. The stage moves to that area. I will now enlarge it by rotating up the mouse screen, moving the image, and clicking right on the center one. Now I can fine-tune it here, and there I have found the center pad of 9 in the lower left hand of the larger circuit board very quickly. If we want to find other pads, we'll go back over to the large screen, scroll down, get the entire view again, and I will focus up on a through hole in the center top board. I'll click on that center top to find a through hole, and there's a through hole. I want to measure on the edge, and there we are.
That there was a wide view observation on the Hitachi FT110A. Again, applications can range. It's typically circuit board related stuff where that comes into play. If you have any questions on how it might benefit your processes, certainly reach out to us. We can do some videos on your samples and show you what it can offer for your throughput. Another feature that the 110A offers to help with streamlined processes and, again, eliminating the variable of operator is autofocus, and there are two related aspects of the autofocus feature. There's the autofocus function shown on the left-hand side of the screen and the auto approach function. Autofocus is simply how quickly the camera focuses in on a sample piece. Many of you might put your sample in and you have to work with a joystick or a mouse to get it to where you feel it's right, but this takes a question mark out of that and puts it on the system to focus quickly, and it's very quick. You see there about a 70% reduction in time from conventional or older X-ray fluorescence equipment. Autofocus happens within 3 seconds of getting it on the sample. And then the other aspect of that is the auto approach, which is actually moving the X-ray head to a certain focal depth so that you are getting consistent readings across the board, even if your depth of measurement varies. So that's considered distance variation, where you might take one measurement at 3 inches, go down to a 2-inch part, and the machine, the analyzer, will automatically adjust for that difference and help streamline the process. Again, you don't have to add additional calibrations. There's no extra steps to seamlessly get from one spot to another and get consistent results. A little more on the distance variation. We have some results up here. It goes 80 millimeters, and you can see that over the course of these examples, gold and nickel, that the error doesn't change too much. It's all within the 5% plus or minus, and that screen there on the right shows the camera, which is actually moving up and down with the component.
If I may step in here for 1 second, this is Bob.
Sure, this is Bob. Everyone.
This feature is very useful for different samples of different levels, say microwave housings I've seen in the past. Any place you've got to measure down inside of a depth where the sidewalls stick up. This is a useful feature, and Hitachi has done a great job with this, where we can go up to 3 inches deep, just over 3 inches deep. And the camera is independent of the head, so we can move the head up and down so that we can measure deeper into these recesses, but the camera has its own slide within the head, and it allows you to focus down in there. So I've seen systems in the past where you could raise the head, but your camera was no longer in focus, so you had no way to control the height. We've solved all these problems in the Hitachi system, and we'll show a little bit more about this in the video. Go ahead, Jeff.
Thanks, Bob. Need a drink of water, so that worked out great. Automatic focus. Why you would want to add the autofocus? Again, it's all about efficiencies. You can increase your throughput by eliminating the focus time. It replaces a reliance on the operator to properly focus, and it has that added benefit of distance variation or deep mode, where you can eliminate several calibrations when measuring samples at various depths. So now it's time for another demo. In this, it's actually 2 videos back to back. The first one will be showing the autofocus function. The second one showing both autofocus and auto approach in a different way. So we'll be back in a moment.
Now I will show you the autofocus feature. With our image monitor screen open, I have placed a standard on the stage, and I will push autofocus. Stage is in focus, standard is in focus. Let me remove that standard and watch how quickly it focuses to the next stage height. That's the bare stage. I'll put the standard back in, and instantly it focuses again. I'll show you once more.
Now moving to the combo video.
Let me now show you autofocus and auto approach. We have 2 samples on the stage to simulate different focal heights required. One is 1 inch higher than the other. This is the lower sample. You can see it's already in focus. Let me slide it over to the 1 inch higher sample. the camera moves into focus, but our head did not move, just the camera. I want to move the X-ray tube head so it's at the same height as the last measurement, so I will hit Auto Approach. The head moves and automatically focuses. I'll now move back to the lower one and show you reverse. Automatically moves the camera, but our head did not move. It indicates the head movement over here in the green arrows. We want it to be at the red mark here. That's that focal depth that we calibrated at. Let's hit Auto Approach. It moves the head to the distance we calibrated at. Readjust the camera. It's just that easy. Thank you.
So that was our summary on autofocus and auto approach on the 110A. And just want to let you know that we're coming close to the end of it. So if you have any questions, we did get a couple through, but send them over, and we'll look forward to tackling as many as we can at the end. Last part, after you add your calibrations, you have your sample alignment streamlined and efficient, you've taken measurements, now it's time to get into reporting. And the Hitachi FT110A comes with 3 options for reporting, 1 in Word and 2 in Excel. Word is a great way when you are reporting on individual sample. The video in a moment will show an example of this, but it's a very detailed 2-page report. You can include the information that you need, calibration used, parameters relating to the measurement, the date and time, spectrums, sample image results, everything you would need in order to relay the right information on to your peers or vendors or clients. Then Excel, there's 2 options, and this is more commonly used when you're reporting on a series of measurements. You've gone through a lot and you have all your data. You can either do it in a simple Excel worksheet, customized to your needs, and it would include trend lines and results of those samples, and then a visual basic report is another option. That allows for a pop-up screen where the operator enters specific information to that series of measurements, like the lot numbers, part numbers, so they can auto-populate and just be more streamlined on the back end. I believe that the video covers a Word example and the Excel worksheet. Visual Basic may not be on there. If that's something that's of interest to you, certainly reach out to us and we can get you some videos and some information on how that functions and how it might be a benefit to you. So those are the reporting options, and now it's demo time.
Let's go over the reporting features of this XRF. We're into one measurement example right now. We have a 389.1 microinch sample measured, and I want to do a detailed report on one sample. So we're going to hit Other, Report, Output Image. This will show us exactly where on the image we measured. I'm going to adjust the spectrum to give me the image that I want in my report. Hit OK. This is a Word report automatically written for you. It shows you the measurement conditions that the system used, the spectrum, the sample where we measured it exactly, and the result. You can also come up to the very top and type in a header if you choose. Let's move on to a sample where we've done many measurements, not just one. We'll go to routine where I have 5 measurements here. We'll come up here and hit the Stats button. That automatically puts our 5 measurements into Excel. You can manipulate this however you want in Excel, report it as you like, but there are some built-in report features in this software. So let's go to Add-ins, Test Report. Here is a nice feature where you have a data input dialog box. Your operator knows exactly what to fill in, and it automatically will be put in the report. So for customer, we put in Hitachi for this case. They can edit the date, the sample number, lot number, another number, manager, and operator. If those titles don't fit your needs, a supervisor can come in and edit those to be whatever heading title you'd like, plus add more. We'll hit OK. The test report is complete. You can see we have our logo up on top in the upper right hand corner. You can put yours in there with your address and your phone number. The customer name shows up, the sample number, lot number, all that is put in along with the date. The 5 results are shown right here. Over here on the right, you can actually make a judgment call whether it's okay or not okay. And you can come down here and put in a comment section for that report that you might send to your customer. If this report is more than you need, and you simply want a printout of your results here, you click on the printer icon here, and if you want to save your results, you put on this save button here, and you hit lot end, and it will automatically print and save the reports just like this.
All right, so that brings us to the end of the last video of this. So I don't want to toot my own horn, but I predicted this to be around 30 minutes, and we're at 30 minutes and 30 seconds, so that's pretty great effort on my end. So now we can tackle any questions that came through. If you have any that pop into your mind, toss them out there and we'll get on them. Bob, you're going to probably be the one that answers these. We've got one from Ryan. Asks, can I add more pure elements to the library, or do I need a technician to do that?
Oh, okay, no problem. Yeah, the library is open to everyone. You can add an element to the library at any time. Hitachi software is very open. There is no limits to what you can enter. All your calibrations are available to you, unlike some vendors where they do require a technician to come in to add a new application. All applications are available. The infinite library, all you do is select one from a drop-down, set your pure element standard in and measure it, and it's automatically stored into that location. You can update it at any time as well. Thank you for that question.
Yeah, and then there was a question relating to pricing of the FT110A, and that is, it can vary greatly based on what features you require, the configuration. So we'd ask that you just touch base with us. We'll probably try to follow up just to see if we can help answer any questions after this and get you ballpark pricing or specific pricing that you would need to consider for your applications of interest. And another question here, this is probably Bob's. Ivan asks, does the measurement head have to be set at the level that an application was calibrated at?
That's a good question. Because this is a deep mode setup, and it doesn't have one fixed head height. We can calibrate at a fixed head focal height of, I think it's around 0.6, all the way up to just over 3 inches, depending on how deep you need to go in to a sample, to a recess. Okay. You would want to measure at the level that is calibrated, and if you noticed on the right-hand side of the image, there was a red mark that indicated the height that it was calibrated at. However, we also have what's called a free mode, where if that was selected during the calibration and it wasn't in the example there, you can put a part in anywhere from the ½ inch up to 3 inches away from the head, and the calibration automatically adjusts and measures correctly. So you do not have to adjust the head to the predetermined head height as long as you calibrate it in the free mode. Hope that answers the question.
If not, Ivan, reach out to us and we can clarify. And anyone else, if there are any questions that come up after the fact, I believe you'll be getting copies of this demo in an email follow-up. Certainly review it and let us know if any questions come up after the fact. As I had mentioned, we can do specific videos to your application or sample interests. We can do webcam demonstrations, and we really work hard to do on-site demonstrations whenever possible too. So I hope that this has been interesting to you all and offered a little bit of insight on what the newest X-ray fluorescence can offer for throughput and streamlined operation in the quality control end of coating thickness. If you have any questions, reach out to us, and we appreciate your time today. Thanks a lot.
Bye-bye.
Bye.